Welcome to this deep dive.
Okay.
We're going to be exploring
Yeah.
a pretty fascinating question, I think.
Yeah.
What happens when physics and AI collide?
Hmm.
We're going to be looking at physics science for AI,
Okay.
PS4AI for short.
Right.
And we'll be using this research paper
Okay.
called AI Meets Physics, a comprehensive survey
Mm-hmm.
to guide our exploration.
Right.
Really, our mission today is to kind of get a grasp on how physics can be used to understand AI,
Yeah.
but also to advance it.
Absolutely. And I think the potential here is remarkable.
Yeah.
To think about AI systems that are not only super powerful,
Right.
but also more transparent,
Yeah.
reliable, and really rooted in the laws that govern the universe.
Yeah, it's a pretty big idea.
It is.
So to really dig into this whole PS4 AI thing,
Okay.
let's first address this black box problem
Yeah.
that the paper brings up
Right.
right at the start.
Right away.
It feels like everyone's talking about AI these days.
Especially-
But, sometimes even the experts don't fully understand
Yeah.
why it works so well.
Totally. And deep learning has really revolutionized AI.
Yeah.
But it often feels like we're just throwing data into this magic machine,
Right.
getting incredible results,
Right.
but with very little insight into the how or the why.
Right.
And so this lack of understanding then becomes a real issue when we want to improve these systems or use them in areas where trust is super important, like in healthcare.
Right. Or like self-driving cars.
Exactly.
So that's where physics comes in.
Yeah.
Like we need someone to open up the hood and show us what's going on.
Precisely. Physics has always been about finding those fundamental principles that explain the complexity of the natural world.
Yeah.
And PS4AI aims to apply that same approach to artificial intelligence,
Oh, yeah.
using physics to illuminate the inner workings of these black box AI systems.
I see. And the paper actually breaks down how different branches of physics could play a role.
Yeah.
Like classical mechanics,
Mm.
electromagnetism,
Yeah.
statistical physics, even quantum mechanics.
Absolutely.
It's almost like each area offers its own unique set of tools to understand AI
Exactly.
in a new light.
Yeah.
So, for example,
Yeah.
Noether's theorem
Yeah.
from classical mechanics,
Mhm.
it states that for every continuous symmetry
Yeah.
in a physical system, there's a corresponding conservation law.
Right.
Okay, I'll be honest.
Sure.
My physics is a little rusty.
Okay, no problem.
Can you break that down?
Of course. So imagine a spinning top.
Okay.
No matter how it rotates its angular momentum, a measure of its spin stays constant.
Mm-hmm.
That's a conservation law.
Okay.
Noether's theorem links this conservation of angular momentum
Yeah.
to the symmetry of the spinning top,
Okay.
meaning its laws of motion are the same no matter how you rotate it.
That makes sense.
Yeah.
So is the idea to find these kinds of symmetries within AI algorithms?
That's precisely it.
Okay.
That's what researchers are exploring. If we can understand the underlying symmetries in deep learning algorithms,
Right.
we might be able to design AI systems that are inherently more robust
Okay.
and efficient.
Yeah. This is where things start to get
Yeah,
like really groundbreaking.
it is.
Another area the paper highlighted was geometric deep learning.
Okay.
And it seems like a lot of the deep learning we hear about works best with data
Yeah.
that fits neatly into a grid,
Yeah.
like images.
Right.
But what happens when you have data that's a bit more unconventional?
That's where geometric deep learning comes into play.
Okay.
The paper refers to this unconventional data as non-Euclidean.
Okay.
So think about social networks, which can be represented as complex graphs,
Right.
or the intricate structures of proteins, which are often modeled as manifolds. These types of data don't conform to the typical grids that traditional deep learning thrives on.
So how do we apply deep learning to these more complex, abstract structures?
Well, that's where physics lends a hand again. Geometric deep learning borrows concepts from geometry and topology, branches of mathematics that are really deeply interconnected with physics.
Okay.
By drawing upon these concepts, researchers are creating algorithms capable of navigating the complexities of non-Euclidean data.
Wow.
It's opening up a whole new realm of possibilities for AI applications in fields like social science, biology, and material science.
That's incredible.
Yeah.
It's like we're giving AI the ability to see the world in a completely different way.
Totally.
The paper also delves into something called Hamiltonian and Lagrangian neural networks.
Oh,
Now, those terms ring a bell from my physics days.
All right.
Something to do with energy, right?
You're exactly right.
Okay.
Hamiltonian and Lagrangian functions are core concepts in classical mechanics.
Yeah.
They provide a mathematical framework for describing the energy and dynamics of physical systems.
Right, like a swinging pendulum or the orbits of planets.
Exactly.
So are we essentially building AI that understands physics at like a fundamental level?
In a way, yes, these neural networks are being designed to incorporate physical laws directly into their learning process.
Wow.
This is especially exciting for areas like robotics, where AI needs to understand and interact with the real world,
Right.
taking into account things like gravity and inertia.
Yeah, it's almost like we're teaching AI the rules of the game.
Exactly.
Speaking of efficiency, I noticed the paper also mentioned knowledge distillation.
Okay.
Is this about making AI run faster?
That's a great connection.
Okay.
Knowledge distillation is a bit like the process of distillation in chemistry.
Uh-huh.
You're essentially separating and purifying the most essential components.
So how does that work with AI?
Well, it involves transferring the knowledge from a large, complex AI model to a smaller, more efficient one.
Okay.
It's kind of like having an expert teacher pass on their knowledge to a student.
I can see how that would be useful.
Smaller models require less computational power and can be run on devices with limited resources, making AI technology more portable and energy efficient.
Right.
It also opens the door for wider adoption, especially in areas with less access to advanced computing infrastructure.
That makes a lot of sense. It's like we're making AI more sustainable and accessible
Absolutely.
for everyone.
Oh, yeah.
But, we can't talk about the future of AI without mentioning quantum mechanics.
Right.
And the paper seems to suggest that PS4 AI could really shake things up in this area.
Absolutely. This is where the possibilities become truly mind-boggling.
Yeah.
Quantum computers, while still in their early stages, have the potential to revolutionize computing by leveraging the principles of the quantum world.
I've heard about this concept of quantum deep learning.
Yeah.
Is this where AI gets its superpowers?
It's definitely a frontier with immense potential.
Okay.
Although it's still very much in its infancy,
Right.
quantum deep learning, or QDL,
Okay.
explores the design of AI algorithms specifically for quantum computers.
Okay. And remember, quantum computers can perform certain calculations exponentially faster than classical computers.
So what kind of impact could this have?
Well, imagine AI algorithms capable of cracking the most challenging problems in medicine,
Yeah.
material science, or cryptography at speeds that are currently unimaginable.
Right.
We're talking about a potential paradigm shift in how we approach scientific discovery and problem solving. But QDL isn't just about raw speed. It opens up totally new avenues for designing AI algorithms.
Right.
Quantum computers can take advantage of these phenomena,
Yeah.
like superposition and entanglement.
Okay.
These just don't exist in classical computing.
Yeah.
This means we could see AI systems
Yeah.
with capabilities that are fundamentally different from anything we have today.
So PS4 AI isn't just about improving the AI we already have.
Right.
It's about redefining what AI can even be.
Exactly.
It's like opening the door to a whole new dimension of
Yeah.
possibilities. It really is. It's about merging two of the most powerful frameworks we have for understanding the universe.
Yeah.
Physics and AI, and who knows what incredible advancements
Right.
might emerge from this fusion.
This is all incredibly exciting.
Yeah.
But I'm also curious about how this relationship works in the other direction.
Okay.
The paper mentions that AI can be used to solve problems in physics.
Yeah.
It seems like a real two-way street.
Absolutely. Just as physics can inspire and guide the development of AI, AI can also serve as a powerful tool for physicists.
Okay.
For instance, AI is being used to analyze the massive data sets generated by particle colliders,
Okay.
simulate incredibly complex quantum systems,
Right.
and even search for new fundamental particles.
So it's not just about making AI smarter.
Right.
It's about using AI to unlock these deeper secrets of the universe.
That's a great way to put it. This synergy between physics and AI has the potential to dramatically accelerate scientific discovery in ways we're only just beginning to grasp.
Before we get too lost in the cosmos,
Sure.
I do want to circle back to something else the paper highlighted.
Okay.
The role of statistical physics in understanding AI.
Right.
This one feels a little less intuitive
Okay.
to me. Can you shed some light on that?
Of course, statistical physics is all about understanding systems with a vast number of interacting components,
Yeah.
like atoms in a gas,
Okay.
or intriguingly, neurons in the brain.
Right.
Many of the mathematical tools and concepts developed in statistical physics can be applied to understanding the behavior of these large, complex neural networks that power AI.
So are we saying that AI is basically like a giant, messy gas cloud?
Not quite, but there are some interesting parallels.
Okay.
For example, think about the concept of entropy,
Uh-huh.
which measures the level of disorder or randomness in a system.
Okay.
In statistical physics, entropy is used to describe how systems tend to move towards equilibrium.
Right.
Researchers are exploring whether similar principles can be applied to AI to understand how algorithms learn and generalize from data.
That's fascinating. The paper also touches on something called chaotic neural network,
Right.
which, to be honest, sounds a little bit unsettling.
Yeah.
Does this mean our AI is going to become unpredictable and wreak havoc?
Not necessarily.
Yeah.
In this context, chaos refers to a very specific type of behavior in dynamical systems.
Okay.
Chaotic systems are deterministic,
Uh-huh.
meaning their behavior follows specific rules, but they are extremely sensitive to their initial conditions.
Right.
Even tiny changes in the input can lead to dramatically different outcomes.
Okay, like the butterfly effect.
Exactly. The idea that a butterfly flapping its wings in one part of the world could eventually cause a hurricane somewhere else.
Right, so how does this chaotic behavior relate to AI?
Well, some researchers believe that harnessing the power of chaos
Yeah.
could lead to AI systems that are far more adaptable and creative
Okay.
in their problem-solving abilities. Imagine an AI that can explore a vast range of possibilities,
All right.
coming up with innovative solutions that we might never have considered.
That's both intriguing and a little bit daunting.
It is.
Makes you wonder what other surprises might be lurking within this field.
Exactly. It's a field filled with both promise and potential pitfalls.
Right.
But that's what makes exploration so exciting, isn't it?
Yeah.
It's about pushing the boundaries of what we know and venturing into the unknown.
Speaking of pushing boundaries, let's talk about Boltzmann machines.
Okay.
I have to admit, this is where my physics knowledge starts to fade.
All right, no problem.
What are these exactly?
Boltzmann machines are a type of neural network inspired by, you guessed it, statistical mechanics.
Okay.
Picture a network of interconnected neurons,
Huh?
each of which can be in one of two states, like on or off.
Okay, I'm picturing a giant light switch panel.
Perfect analogy.
Okay.
Now imagine that the connections between these neurons have weights, representing the strength of their interaction.
Right.
A Boltzmann machine learns by adjusting these weights to minimize its energy, a concept borrowed from physics.
So it's like the AI is trying to find the most stable, lowest energy state, just like a physical system.
Exactly. By finding this optimal configuration, the Boltzmann machine can learn to represent complex patterns in data.
I'm starting to get the picture, but what are these Boltzmann machines actually used for?
Sure.
What kind of real-world problems can they solve?
They've been used for a wide range of applications, from image recognition and recommendation systems to modeling the behavior of physical systems themselves. However, they can be notoriously tricky to train.
So they're kind of like the brilliant but temperamental artists of the AI world.
That's one way to put it, despite the challenges.
Okay.
Boltzmann machines represent a powerful tool for both understanding and building increasingly sophisticated AI systems.
Okay, one last concept I'd like to discuss before we move on.
Right?
Generative adversarial networks, or GANs.
Okay.
They seem to be getting a lot of attention lately.
They are indeed. GANs are a particularly fascinating type of neural network architecture
Okay.
that pits two networks against each other,
Right.
a generator and a discriminator.
Okay, now I'm really intrigued. What exactly are they competing over?
The generator's role is to create synthetic data that closely mimics the real data it was trained on.
Okay.
Think of it like a master forger trying to create a perfect replica of a famous painting.
Right.
The discriminator, on the other hand, is like the art expert whose job is to spot the fake.
So they're constantly trying to outsmart each other like a never-ending game of cat and mouse.
Precisely through this adversarial training process.
Yeah.
Both networks become increasingly sophisticated.
Okay.
The generator gets better at creating convincing fakes, and the discriminator gets better at sniffing them out.
What's the ultimate goal of this AI arms race?
Right.
What do we gain from it?
The end game is for the generator to become so skilled that it can produce synthetic data that's virtually indistinguishable from the real thing, even fooling the discriminator.
Wow.
This has incredible potential in a variety of fields, from generating realistic images and videos to creating new music and even writing text that mimics human language.
So GANs are like the creative powerhouses of the AI world.
Yeah.
Constantly pushing the boundaries of what's possible.
That's a great way to think about it.
Yeah.
GANs have already led to some remarkable breakthroughs in AI, and we're only just beginning to scratch the surface of their potential.
Wow. We've really journeyed deep into this world
We
with
have.
PS4 AI today.
Yeah.
From that black box challenge to the mind-bending possibilities of quantum deep learning.
For sure.
It's clear that this is so much more than just like a passing trend.
Yeah, I think it's a pretty profound shift
Yeah.
in how we think about and develop AI.
And what's been so striking to me throughout our conversation is how interconnected these two fields really are.
Right.
It's not just physics inspiring AI, but AI also becoming this really invaluable tool for new discoveries in physics.
Yeah.
It's this like beautiful feedback loop of advancement.
Precisely. AI is rapidly becoming an essential tool for physicists.
Yeah.
It's helping us analyze incredibly complex data, simulate these intricate systems,
Right.
and even design entirely new experiments.
Wow.
And as these AI systems become more deeply rooted in physical principles,
Yeah.
they'll be even better equipped to tackle some of the most challenging questions facing science and society.
Speaking of challenges,
Okay.
the paper we've been discussing
Right.
doesn't shy away from the open questions
Yeah.
and potential pitfalls of PS4 AI.
Right.
It raises some interesting points like,
Yeah.
how do we ensure that the physical principles we're incorporating into these AI systems
Yeah.
are accurate and reliable?
Right. How do we avoid introducing biases based on our current understanding of physics?
Right, because that's constantly evolving.
Which, as we know, is constantly evolving. Exactly.
And there's also the question of complexity. Some physical systems are just incredibly challenging to model,
They are.
even with our most advanced mathematical tools.
Absolutely.
So how do we translate that complexity into something that AI can actually work with?
That's a key area of ongoing research in PS4 AI.
Okay.
One approach is to develop entirely new AI architectures that are specifically designed to handle the unique complexities of physical systems. Another promising avenue is to use AI itself
Okay.
to help us develop simplified models that capture the most essential features of these complex phenomena.
It seems like PS4 AI is pushing the boundaries of both physics and AI,
It is.
forcing us to re-examine what's possible in each field.
Absolutely.
It's truly a remarkable interdisciplinary endeavor.
And that's what makes it so incredibly exciting. We're really just at the beginning of a journey
Right.
that could lead to profound advancements in our understanding of the universe and
Yeah.
our ability to solve some of humanity's most pressing challenges.
What does this all mean
Right.
for you, the listener?
Yeah. Why should you care about PS4 AI?
Yeah.
Well, think about it this way. This field has the potential to impact virtually every aspect of our lives.
Okay.
Imagine a world with more reliable and efficient energy grids. Personalized medicine tailored to your unique genetic makeup.
Wow.
Or self-driving cars that navigate with the precision and grace of a ballet dancer.
It's about AI that truly understands the rules of the game,
Exactly.
operating not just with data, but with the fundamental laws of nature.
And that's a complete game changer.
Well, I don't know about you, but I'm feeling incredibly inspired
Me too.
and ready to delve even deeper into this world of PS4 AI.
Yeah, it's a field brimming with possibilities.
As we wrap up,
Okay.
here's a final thought-provoking question
Right.
to leave you with.
Okay.
If AI truly begins to understand physics,
Yeah.
what are the implications for scientific discovery, technological innovation, and even our understanding of the universe itself?
It's a big question,
It is a big question.
but one that's certainly worth pondering.
Thanks for joining us on this deep dive
Yes, thank you.
into the fascinating world of PS4 AI.
It's been a pleasure.
We hope you learned something new and are just as excited about the future of this field as we are.
Absolutely.
Keep exploring, keep questioning, and keep pushing the boundaries of what's possible. Until next time.